you everybody for coming to our first guest lecture event. Our speaker tonight is Dr. Kevin Folta. Dr. Folta received his bachelor's and master's degrees at the University of Northern Illinois. Thereafter, he earned his PhD in molecular biology at the University of Illinois at Chicago. In 2000, Dr. Folta completed a postdoc at the University of Wisconsin in the lab of Dr. Edgar Spalding. And in 2002, joined the faculty of the Horticultural Sciences Department at the University of Florida, Gainesville, where he's also departmental chair. Dr. Folta's own research includes plant photomorphogenesis and strawberry genomics and flavor. Dr. Folta has received several awards, including the NSF Career Award and the Howard Hughes Distinguished Mentor of Undergraduate Research. He has been an outspoken proponent of GMO science and has had several workshops across in science communication across the country. And we're excited to hear from him tonight on both topics. So please join me in welcoming Dr. Folta.
Well, from the sound of that, there are 32 people. No, hi everybody. It's really a pleasure to be able to do this. This is tonight in upstate New York. I was earlier today in North Carolina with the same topic. So fun to be able to use electronic media to do this. And this is a really important topic in science communication because it really is an excellent way for us to look at what we've done wrong and understand what we've done wrong and then adjust and then do it right. And I think we are finally starting to understand how to connect with people about this really important topic. Normally I'd ask you a bunch of questions, but I can't see you at the moment, so I'll just keep rambling for another minute. Uh-oh. Everything good?
Can you see the crowd?
Oh no, all I see is my slide.
Oh, okay.
I'm only on my monitor at the moment. So back when genetic engineering really started, you had companies that rolled this out and didn't bother to ask people how they felt about it. It was just pretty much a case of, we have this technology, we're going to use this technology, and don't worry about it, it's just fine. And the problem is that when you do that, you're not being super transparent. You're not rolling out the technology in its best way. And you also have a situation where if it is really sciencey and maybe a little scary because you're messing with traits with DNA, people could misunderstand what's happening. Now, you do that at the same time as you're having the birth of the internet and the expansion of industries which survive on bad information and misinformation, and you create a perfect storm to generate to malign a good technology. So one of the central problems here has been a lack of good communication. When we finally realized, and I'm not an industry guy, I'm a public sector scientist, we finally realized we were doing it wrong. It was too late. We really needed to be talking about this better from the beginning. So what I'd like to do is talk to you about how to talk to people about science and kind of use this area of genetic engineering as a case study. How do we learn from our mistakes here, and what can we do going forward? And first thing we'll talk about is why there's a problem with acceptance. How do we communicate this effectively, and how we can really expand that by using lost opportunities. What are the things that we didn't do because of of technology? And what we know, this comes from the Institute of, or I'm sorry, from IFIC. They say that when they poll people, whether it's moms, millennials, early adopters, or foodies, safe and affordable food is an important thing for everybody. Everybody wants safe and affordable food for their families. And this is a great place to start because it really reminds us that everybody really is, at the end of the day, on the same page. We want safe and affordable food. We want lots of choices. And those of us in the industrialized world, that's really what we're looking for. And we'll talk about other important values around food in a few minutes, because that's really our way to solve the problems in the communication side. But it really gives us, the reason I show this is because it gives us a kind of nucleus for us to be able to guide any conversation. There really, we can say we all care about the same thing. We're all interested in safe and affordable food for our families. Oops, there it is. The big problem is affordable.
I think the slides aren't moving on this screen.
Oh, they're not. Are you really on the
They're on your other screen. Yeah.
Hang on a second. Because it's moving over here. Just let me do that.
Yeah, now we see you.
All right. So there's this slide. Hi, everybody. Now I can see everybody. Gotcha. So maybe what I'll do is I'll just work from the PowerPoint thing here. Let me see it. So if I show you, can you see this slide here?
We still see you.
How about that? You can see
yes.
Let me just work. That's fine. Now I can see you too. So don't go to sleep. So let's do that. Okay, that looks pretty good, right? All right, so if we talk about this slide, it really talks about the reasons we genetically improve food. We can have better variety, more yields, improve nutrition, be able to come up with crops that grow under different conditions. And so these are things that for 20,000, we've taken the wild that are out there and changed them in order for them to fit what we need them to do. And that's what genetic improvement really is. But if you ask people in the public what is, they think it's something very different. And you should see the slide now with the lettuce pig. Okay.
Yeah.
So people think it's something. How do we what this is about? And the public has very little understanding. If you ask people, and this is a great example here, a survey by Oklahoma State last year was, we asked people, do you support or oppose government policies for, and here, mandatory foods produced with genetic engineering? And something like 80% people said, yes, we support. But if you ask people other questions like, do you support mandatory labeling containing DNA? 80% and a margin of error also support labeling food that contains DNA. That people will respond positively to labeling food. So it really just shows that the consumer isn't sure, and the consumer doesn't understand, and maybe the consumer's kind of scared too, and that wouldn't be surprising. So, what are some of the other barriers we have to contend with? The public are naturally going to want to. We also see this manufactured risk. We'll talk about that briefly. And then other motivations people have to be against science. And then we still are dealing with the issue that there are a lot of people who think they're doing the right thing that actually are doing something very negative. That by standing up for a kind of misplaced activism, they actually harm someone. And that's not a good thing. Now, we have a lot of folks who are making money off of that information. And whether you're looking at Babe or others, there's a lot of money that's being made off of, like this guy sells all kinds of stuff on his website, so does Mercola. Rather dubious information on this topic. And it's very important for us to understand that this isn't just science, and a lot of the are coming from. And that's because the ideas about agriculture are very important. They penetrate very well. And what's happening, you have people with a very unfavorable review of the science. On one end, activism. You got farmers and scientists over here. Most people are right in the middle, that they don't understand this technology very well. And so how do we communicate? Activists, Dr. Oz, Food Babe, they use fear. They scare people about farming and telling them about how hurtful it is for their families. On the other hand, on this side, where farmers and scientists are saying, well, you know, we have the degrees. Clearly, we think it's fine. Don't worry about it. It's safe. Here are some statistics. Here's a graph I can. And so in that battle, heart and the head, between fear and facts, you can tell which one wins. And it's fear. So scientists don't communicate on this topic very correctly. And this is really the big problem. So what I'd like to show you are ways that folks who are in the space and in the public interaction space, either with farmers, scientists, food-related industries, better can connect with audiences and teach about the facts of genetic engineering for any science. This also fits with vaccines, stem cell research, organ transplants from pigs, immunobiology can be done. So what do we know about the way we have to communicate with an audience and that doesn't necessarily understand? And here I'm showing you a classic battle of fear versus facts and how facts always lose. How are we going to do this? And the way that I encourage you to think about this is a very classical Aristotle framework of logos, pathos, and ethos. We're talking about logic versus pathos and emotion. And ethos, which is really the ethics of this, right? It's what the values of the credibility of this. And the way that we're looking for is logos versus what I'm suggesting, many are suggesting change the thinking on a scientific issue, is to really lead with our ethics. Let ethics be our first start. So instead of beating people to death with facts and figures, or crying about it and scaring people, how do we start with ethics? What do we all care about? What are our common values? And when you start with that, I think we make a very compelling argument. So I'm going to slide down a couple slides here. And when I talk about this, I talk about the areas that I really like to serve. I really like to think about the environment. I think about doing science because it helps farmers. I think about science because it helps the industrialized world. And I think about science, what we do can help. The developing world and food safety, those are okay too. But the main way that we really need to, so if we want to talk to somebody who's about genetic engineering, for instance, instead of saying, you know, I can say, why don't you like technology? And they'll say, well, I don't like it because it all goes to profit Wall Street and shareholders, and they don't care about the rest of the world. And I'll say, well, let me tell you about what my lab did and what I think is good. And I think the environment, consumers, and the needy are. And I really want to work for them. And here are some tools that I use to help them and to help those causes. You care about those causes too, right? Yeah. So it gets everybody on the same by sharing our ethical basis. And I'll show you some ways to do that in the area of genetic engineering. The other big issue is, a couple other issues, is how do we personalize that message? And the problem that science is that it's so cold. And if we can personalize it by saying, these are technology that grow on my farm, or situations that I need my family, it tends to also go a long way helping consumers in the science. All right, so here we go down here. Okay. The other big issue is that it's important to remind people that technology comes from many different places. That genetic improvement is a very long process, 10,000, 20,000 years. And this map is a really nice thing to find. If you look on centers of origins of selected crops, I see you leaning forward there. Maybe I can make it bigger. You can see, you know, sorghum from Africa, lettuce, beet, sugar beet, our Mediterranean, grape, Mediterranean, that barley and wheat from the Mediterranean, where citrus and rice are from Asia, sugarcane Asia, soybeans from China, apple from Kazakhstan. Really amazing that not too much comes from North America, at least the United States and Canada. Not very much. And the reason I like to talk to people who are nervous concern is because it reminds us that humans play a role in plant genetic improvement, and that everything is a foreign body on our soil. That humans move. Humans have always done those genetic changes that allow them to be grown on our soil and compete in our ecosystem. None of this is natural. And that's a really important point. Another important point is looking at where plants were and where they are today. This is what like 20,000 years ago. This is modern. This is modern tomatoes, the wild banana and modern banana. All of this has been done by humans that have shaped the genetics and for thousands of years. We have no idea what we're doing. Plants have constantly been changed for human consumption. So what we do today is the next step. So you can see the way that we change where plants were originating and where we've moved them, and how we've changed them genetically. They're really nothing like what they were in nature. So that whole idea of I don't like it because it's not natural goes right out the window. There's really just four crops that humans do. And this is always a point of communication, because it reminds people that this isn't every fruit and vegetable you're eating. It's actually a few ingredients in most processed foods. Now, potato and apple are not available yet. They've been degraded. There's only a little bit of squash that's genetically engineered that's available, and we don't eat alfalfa and cotton. So corn, soy, sugar beets, and canola, really just four different crops that we're eating the products from. And it's a little bit of sugar beets, canola oil, cornstarch, corn oil, and flour, corn flour, and soy products, soy milk, soybean curd, all the things you get from soy. So when you're looking at something that says cornstarch, genetically from genetically engineered corn, sugar from sugar beets, canola oil from canola is identical to the non-genetically engineered. You can't tell them apart, which really makes the whole labeling issue very difficult, because this product is identical, genetically engineered or not. All of the DNA and proteins that are genetically engineered plants are wrong. The only thing that's left. So let me shoot ahead here really quick. And what I would like to talk about, well, let me go back. I want to leave plenty of time for questions. Today, there's really just three traits that are being used in genetic engineering. And I think it helps people to understand that as well. They think there are all kinds of modifications that are made, but it's really just resistance to viruses, which is in papaya and squash, resistance to insects, which is in cotton, resistance to herbicide, which is in the sugar beets, soy, cotton, and corn, and alfalfa. And it's really just these traits. And I can talk a little bit about this briefly. Insect resistance is a trait where it's a protein present in bacteria that's toxic to certain pests that are in their larval state. Corn earworms that eat the corn, the bacterial protein is poisonous to them. And scientists simply move that bacterial protein from the bacterium to the corn. So the corn makes its own protection. That same process all other animals. Herbicide allows the plant to grow. An herbicide called glyphosate affects a very specific enzyme. So when you put in a different version of it, it makes the corn immune to that herbicide. And it works really well. We'll talk about that later. But these kinds of traits, insect resistance, herbicide resistance, nobody gets too excited for them. Excuse me. And they're not a good way to lead a discussion on these technologies, because these are the traits that companies did way long time ago and used safely for 2020, but consumers don't know the effect of these. And so what can we talk about where consumers can get excited? And this is where we go back to our shared values, our shared ethics, our ethos of farmers, consumers, the environment, and the needy. And the first good example is something like golden rice. Now, golden rice, 40% of people on the planet, 40% of the calories. And rice has very good protein. So people are not getting the stuff that's in carrot. And blindness is very prevalent in a lot of these regions. So this map shows vitamin A deficiency problem. And the hotter the colors, the worse the problem. So you can see that even in throughout Asia, Africa, and South America, evidence of vitamin A. You can engineer really into corn, phytoin synthase and lycopene cyclase, CRT. You can engineer in a couple enzymes and now be able to synthesize beta carotene in a plant where it wasn't originally present. And because all plants have this geranyl pyrophosphate stuff. So you start with this, you add a couple steps from other plants, and now you can create beta carotene where you previously couldn't. And they've made this stuff called golden rice, and it's not perfect, but it's been available for over a decade, well, 15 years now, and still yet to be deployed. And it could be a very important thing in the developing world. And other good example is cassava, where cassava normally is white like this. It's a starchy root that people eat daily in many parts of the world. In Africa, it's a staple. And you can see here how it's been engineered with an orange cast so that you can, it's the beta carotene. It also has higher amounts of protein and iron. And you also can make, this is the picture up on the upper right is cassava brown streak virus. And this is an enzyme, or this is a virus that destroys the starchy root. And you don't really know you have it till you harvest sometimes. So this is a really bad thing for farmers. And you can make cassava that's virus resistant, high in protein and high in vitamin A. And this is, again, something that all of this exists. These are pictures that come from crops that are already existing and tested, but we don't use them. And that's really sad because these are solutions that could be very beneficial for farmers and in the developing world as well as in the industrialized world, but mostly for the developing world. The other good example is bananas, which in many parts of Africa, the starchy banana like a plantain is a daily staple. And that too has been engineered with beta carotene production. So someone can eat bananas that have this high amount of beta carotene, where the beta carotene comes from a gene which was isolated from another kind of banana. It's just much faster than breeding. We know in the industrialized world that peanuts have allergens. And you know there are peanut-free classrooms. You know that people have died from peanut dust exposure. And scientists have been able to engineer out some of the major proteins that trigger that allergic reaction. And this is some kind of technical stuff here that basically shows here are the lines here are the proteins. These black lines are actually the protein in what's called gel electrophoresis. That means that those proteins are present. And in these lines, that protein is turned off. And so it shows that you can now suppress those proteins that trigger the violent allergic reactions in people. That's a really cool thing. You can also do the same thing with bread wheat to lower gluten levels for people who have gluten sensitivity. So there's a great example for in our areas of concern, in our ethical concerns, it can benefit the industrialized world consumer. Healthier potatoes. This is a good one. That potatoes have been made to resist bruising, which is great, and also have lower amounts of this stuff called asparagine. It's amino acid that's in the tuber. They can turn it off. And without that asparagine, you have lower amounts of what's called acrylamide upon cooking, where you cook, anytime you heat coffee or potatoes, you generate a little bit of this acrylamide. And it's a risk factor. You know, it's not significant. It's not a huge risk, but it is a risk. It's a carcinogen. It's also a neurotoxin. And it's present in these vanishingly small amounts in our food. To make healthier French fries, this potato has been developed, and it doesn't bruise, so you can see the bruising on the potatoes below, and it has no acrylamide. The bruising is important because up to 25% of potatoes are used as animal feed or are discarded because they have bruises and consumers won't buy them. Processors won't buy them. So this allows you to have a higher yield. You use the same amount of insecticide, the same amount of fertilizer, the same amount of everything else, labor, fuel, and you get 25% more because you're not bruised. That's a good innovation. Here's a good one from Florida here. These are tomatoes that do not have, so these are tomatoes that are regular tomatoes, and you can see the bacterial wilt. These have a gene from peppers, and that gene from peppers, which is peppers and tomatoes are cousins, protects these plants from that bacterial disease. And so here you're using a plant gene in a different kind of plant that allows you to defeat this pathogen and have much better yields. Between twofold and 11-fold, but twofold is really the better number. And that would be great for our farmers, particularly our organic farmers, because the pest control is copper, and they use 6 pounds an acre, and it's expensive, and it's another heavy metal in our environment. It's nice to get rid of that. So this is good for farmers and maybe good for our environment too. I mentioned earlier in Florida, we have a devastating citrus disease. And you can see the naked branches back here where the leaves are gone and the fruit are sick and drop from the plant. We have a number of genetic engineering solutions here. And this would be great for our farmers. It's great for our environment because we don't need to spray as much insecticide to kill the insect that spreads the disease. It could be a very good thing, but deregulation is still a long way off. I really just gave you a couple good examples there of some of the things, and the other part to remember about this is that all the things I just told you, from golden rice to vitamin-enriched cassava to healthier potatoes and tomatoes that don't need insect control or bacterial control, is that these aren't Monsanto, Bayer, Dow, BASF. These aren't made by the companies that make genetically engineered plants. These are all made by the public sector and small companies. And these could be real game changers. But none of these are in use, even though some of them have existed for 18 years, because of the climate of fear that goes back to the earlier slides. Because people don't understand the technology and build fear around it, we don't implement things that could be very helpful to all of us. And I think that's important from the communication side, that if we really care about farmers, consumers, the environment, and the needy, we need to have all of our tools on the table. We need to have every tool that we possibly can roll out to address these particular problems. And that's the way to really approach this, is from a science communication side. I'll wrap up with a couple of things here. We know that people, that all of the usual psychology plays into this, that people do dig in their heels when you provide them with evidence. That the better your evidence, the more they're going to dig in and push back and say this is bad stuff. And you have to continually go back to the ethics. Is this important to you? Well, why would you reject something that's going to take care of something you really care about? And just when we're communicating about this, avoiding this feed the world rhetoric. It's so off-putting when someone says, oh yes, we're doing this to feed the world. No, we're doing this to keep farmers in business, and we use it to help keep chemicals out of the environment, or we use it to give consumers more choices. That's the reality. We use it to help a family in the western province of Uganda grow bananas that they need to grow for their family farm. That's why we do it. It's good to talk about strengths and limitations. What's good, what's bad. That we talk about the positives and the negatives. And I think that's really important. Really the only negatives we know about are overuse of herbicide for these crops and the resistance that happens. So when you use one herbicide too much, the weeds can become resistant. You see evolution in action. The same thing happens with insects, that you see evolution of insects that work their way around your insect control. And that's one of the key limitations of these technologies. Very important. And it's not something that you do instead of organic agriculture. It's something you do in addition to or along with. And even though it's not in keeping with organic standards now, I really think both of these strategies between transgenic or genetically engineered plants and organic crop production have the same goal. You want to produce more with less, and you want to be able to do this with less environmental impact. That's really the big take-home message. It's good to look at some of the resources online. And there's a lot of very good farmers that are really starting to get involved in this discussion. And I work a lot with farmers and talk to a lot of farmers and encourage them to participate in this discussion because they know more about it than just about anybody else. They understand the traits, they understand the costs, they understand what happens if they don't use it. And so they're very good voices for us to be able to discuss the strengths and limitations of these technologies. So just to kind of conclude, is that the people who really understand these technologies, like scientists, folks in industry, farmers, other academics, are very hesitant to get involved in the discussion. And that we need people to be stepping up, but doing it right and leading with your ethics, talking about why these strategies help things you all care about, whether it's farmers, the environment needy, and the industrialized world consumer, leading with those ethics and talking to the folks in the middle, remembering your audience, that you need to talk to the skeptical center and the people who are just concerned about what their family is eating, that they're the ones who are most important to talk to. And also to know when to check out, that when people are putting up opposition and just wanting to fight about nonsense they've read rather than scientific evidence, it's good to kind of just let them be and not try to educate the uneducatable. The other big deal is to lead with technologies that we could use if we had the courage to use them, and talk about the people that we could help, talk about the environment we could assist, talk about how technologies could be beneficial to things that we all care about. And those technologies exist, but just aren't being used. So those are my major points. So we are kind of, so we're getting down the, really kind of would like to wrap up there and take your questions. You can always reach out to find me. That's my email address, blog and Twitter. I do a podcast that talks a lot about the individual scientific topics in molecular biology and in plant breeding and genetic engineering. And it's always pretty interesting. And it's not all about genetic engineering. It's about crop genetic improvement. And every crop has a cool story and lots of fun. So really interesting guests. If you have any questions in the future, please don't hesitate to call me and just remind me of where I ran into you, okay? So that's my email address. Reach out anytime. I'm super glad to talk to you. So this leaves us with lots of time for questions, and I really hope to answer all your questions and concerns. So thank you very much for your time on this.
Okay, so I thought I would start with just a few questions that we came up with during a discussion session, and then I would open it up to the rest of the audience. So you mentioned not trying to reach some of the extremists, don't try to educate the uneducatable, but at the same time you talked about people who have the best intentions in mind, but they're approaching the topic with misinformation.
Yes.
So are those people folks that we can kind of try to recruit, because they could potentially become a great ally, right? Like Food Babe, she has some good points and then some maybe not so much. So yeah, can you speak a little bit about that?
Oh, you're so right. I agree so much. The Food Babe is a great example, and I've offered to sit and talk about these technologies and answer all her questions, and that would be great. I've converted lots of people who were staunch anti-GMOers, and now they are very pro the technology. I think it's important to spend time to try to talk to people always. And that people who disagree with you, it's not just about you teaching them, it's about being open for them to teach you. If somebody disagrees with you, it is like if someone who disagrees with me can convince me I'm wrong, I really am happy to change my mind. I don't want to be uneducatable either. So keep an open mind, talk to people, share ideas. But if people are totally turned off to evidence to the point where they refuse to accept anything that you tell them, then it's good to step away from the conversation. But absolutely do remain open, and remain open to be changed yourself.
And so a little bit more on that. So can we encourage a healthy skepticism in the public, as well as open-mindedness and critical thinking when it comes to things like they see a research paper that's put on in the pop or mainstream media? Is it possible to kind of get the public thinking more critically about those while still maintaining their skepticism?
Yeah, that's a good question too. I think it's so important for us to be better at critical thinking and being better connoisseurs of information. The problem that we have is that there's so much information and so much of it that looks good. And even people with scientific training are sometimes fooled by data and statistics. And so the way to think about it maybe is two levels, is looking at two pillars for scientific validity. One is that peer review process that has to be in a place where it's gone through some rigorous review. That's one pillar. The other side of that is reproducibility. And when you see multiple groups getting to the same point, now you start to think it's a little more believable. So that's really important. I always encourage skepticism and critical thinking in the public. And don't accept any claim at face value. Take everything I've told you, go weigh it against what you've heard elsewhere, and weigh it against the peer-reviewed literature. I think that those kinds of, that's what we should be doing. And then you start to identify people you trust and identify sources you trust. For me in this area, it's things like the National Academy of Sciences. It's the American Medical Association. It's our elite scientific organizations, that they really can help guide me on these particular topics. Things like climate, I'm not an expert, but I know what the national academies say and trust the national academies. So it's good guided skepticism.
And so kind of going along with that same topic, so the public will tend to lump GMOs into one category, and as you showed, we can break them down into resistant crops, crops that are fortified, or crops that prevent ripening. So how can we approach? How can we educate folks on the differences? If they're afraid of GMOs broadly as a group.
Yeah, I think that goes back to the concept of shared values. That it's not all about insect resistance and herbicide resistance. It's about how to use a technology to help things we care about. And it's not about being afraid of technology. Technology, France can run a country on nuclear power, and they don't have to use it in nuclear bombs. We can engineer viruses that deliver genes that allow people to see, and you can have viruses that deliver disease that kill millions of people. The idea is that technology is just technology, and really its power lies in the ethics of the user. That we can do, and that's why I showed you all those examples like golden rice, golden bananas, reduced allergen peanuts and wheat, citrus genes solving citrus problems, because those are areas that we should see as ethical imperatives. It's not making money for farmers and corporations that sell the seeds. These are helping small farmers, and these help the developing world. And those products exist and we don't use them. And I think that's a much bigger crime.
I guess my question also was, so, food labeling inherently isn't necessarily bad, right? But when you say, this product is a GMO, that relies on the consumer to do their due diligence and actually take the time to say, okay, what do I reject or accept this, right? So, I mean, if you want to be a conscious consumer, it's a little bit overwhelming to go down every aisle and look at every, with every product and kind of pick that apart. So, I mean, how can you imagine coming to a solution where the consumer is happy and feels safe and environmentally conscious, but at the same time has that information and isn't threatened by it?
Yeah, that's a good question, because the problem is that you have to have consumers brought up to speed on what it is they're eating, and they're really not very good at that. People don't understand where their food comes from. They don't understand much about genetics. As I mentioned earlier, 80% of people really want to know if there's DNA in their food. That's pretty wild. And the other big issue with the whole issue of labeling that makes me wonder is something like I mentioned, sugar beets. A GMO sugar beet versus a non-GMO sugar beet, they both produce sucrose, table sugar. And when you mash them up and you solubilize all the sucrose in the water, then you dry it down and you get rid of all the DNA and all the protein and all of the fats. That's all gone, leaving you just with table sugar. You can't tell them apart chemically. Sucrose is sucrose. The same with oil that comes from soybeans or from the other thing, canola or corn. It's oil. DNA doesn't go in the oil. It stays in the water fraction that's lost a long time before. So it's hard to tell GMO oil versus non-GMO oil. It's oil. And so why do you have to separate those two things? And what makes one dangerous and the other one not dangerous? That's really such an important question when we look at this, that this is a process, not a product. That the plant is the thing that's changed. The plant has a gene that allows it to do something. It's like whether it was harvested with a red tractor or a green tractor, it doesn't matter. The process isn't important. It's the product. And if the products are the same, then it shouldn't matter and shouldn't be differently labeled. That's just my 2 cents.
Okay, and so we talked about the different demographics of the public and their concerns. So what would you say are the public's biggest concerns? Is it mostly health, food safety? Do they care about the environment? Do they care about ecosystem diversity?
It's really, really scary when you ask that question. And I hope everybody out there does this at some point. If you get into a diverse audience and say, what concerns you about food and farming? What are your biggest concerns? And almost universally, people will say, I need it to be safe, I need lots of it, and I need lots of choice. And then I'll say, okay, well, what else? And they'll say, I don't know, nothing else. That's it. I want choice, I want it to be safe, and I want lots of it. And that is the overwhelming opinion of the American consumer. And if I press them hard enough, eventually someone will say, yeah, well, it needs to be environmentally sustainable. It needs to be able to be farmed without exhausting resources. It has to be something that is farmed with sensitivity to labor markets and people available to do it under humane conditions. You have to be able to have something that's profitable for the farmer. Farmers got to make money. That's a tough job. And if farmers aren't making money, they're not going to do it. And then we got a real problem. And the other issue is the developing world. How do we feed people who, have zero or who have very little? How do we help them how do we help them help themselves? We don't want to save them. Okay, that's not our job. How do we give them innovations and agricultural innovation that allows them to be their own leaders? And so that's really so in the industrialized world, we worry about safe and affordable food, lots of it, and cheap. But try to think about these other things. And some of the best ways to solve those other areas is really by including genetic engineering in our toolbox.
And so you talked about different approaches to the public when addressing their concerns, and how they the same tactics might work in different fields. But certain demographics like the anti-vaccine group anti-GMOs or climate change denialists, they might have very different concerns and different demographics. For instance, with the anti-GMOs, we saw there was a Pew poll that showed the anti-GMO attitudes were kind of universal, and there were minor to no differences between race, gender, religious views, even education. It didn't matter. There were still these anti-GMO attitudes. So do you think that the demographics matter when using these the strategies you laid out?
I think so. But at the same time, it's important for us to remember that when the way that we are most effective in changing the conversation on these things is not by proclamation and not by blogs and websites that try to change their mind through information. It's that facts don't matter, and that's the thing to take home. Teaching people about contentious issues is a personal issue. You have to share those ethics. You have to be a teacher, be a friend, and not be a scientist or an advocate for technology. You have to be somebody who just wants to show that you are on the same page with respect to your interests and your values, that you care about the same things, and that you know about some tools that can help get you there. I think that that's the important thing, is to personalize that message.
And so you talked about, oh yeah, sure. So we have, we have about 13 more minutes for questions. So let's open it up to the audience. Anybody?
Yeah, yell real loud.
Can you hear me if we speak through the mic? All right, great, glad to hear. Wonderful. So this is actually pulling off one of the other questions that the discussion group had last week, but usually for me, when I have conversations of this sort, there is a component of being able to acknowledge the flaws on both sides. They're politics, not something usually in science, but in this case, maybe that's something to consider. So from the perspective of acknowledging that companies that handle the GMOs aren't perfect, and it's impossible to argue, no, these people are completely altruistic and their motives are true, and therefore they require the full support. Is there a better model for patents or for GMO distribution, or on a more broader sense, if this is more specific to something you're interested in, is what are they doing wrong? Like, where can we acknowledge in a discussion that things aren't perfect and also needs to be addressed on the GMO side as well?
No, you're exactly right. That it is about always, and that's one of the points I made about keeping in mind your strengths and limitations, and also say, the companies that did this, they screwed up in the beginning, and the fact that this is large companies that have been fighting for more stringent regulation that only they can navigate, that hasn't helped, and a lot of this comes from an anti-corporate attitude, which I share. And I'm not I found a plastic knife. That's what's in me, which I share. And I think I'm not exactly thrilled with big companies like my bank or my oil company or any cable company. Forget them. I think the idea of saying that a lot of the problems we have today is because of an corporate anti-capitalist attitude, which is out there. And then on top of it, the company's not responding appropriately. Instead of giving us information, they became less transparent. Instead of saying, here's why we understand your concerns, they said, hey, get lost. The other solution, though, it plays into this as well, is that the solutions I mentioned are not from big corporations. And if you're going to change someone's hearts and minds about this stuff, it's to remind them that many of the innovations that can solve problems for things we care about are from universities, they're from small companies, governments, yet still not deployed because of that high boundary set by companies and because of the very rigorous road to deregulation. I hope that answered it.
Okay. You can hear me also?
I got you.
Great. So this is a question about audience. So my understanding, and perhaps this is not correct, is that so on the right, on the political right, you have misinformation about climate change and the war against climate change. On the left, you have these anti-vaxxers and anti-GMO people, which, as somebody on the left, is pretty upsetting to me. What is the kind of educational, and it also seems like it's people of privilege that have these problems, these like crunchy granola, people who go to yoga for like $50 a class and whatnot. And so what is the like education, socioeconomic, demographic of people that we might encounter that we're trying to talk about GMOs with?
Yeah, you know, you're hitting a little close to home with that crunchy granola yoga remark there. You know, and I mean, I tend to lean quite that way socially. I mean, certainly, and I'm always disappointed by folks I know who, you know, it's a primary day down here in my state, and people are voting for people who are outright science deniers, despite you know, well, I mean, in their policies and ideas. And I can't do it. Anyway, that kind of moves away from your point. Again, it goes back to dealing with people one-on-one. There's also the idea in genetically modified food, or I should say genetically engineered food ingredients, really varies a lot, because there's a lot of folks who are on the political right who say this is monkeying with God's creations and should not be allowed. So you get that too. But in terms of audience, I think the big trick is, and the thing that I like is that folks who are left of center or are out on the left, oftentimes you can appeal to ethics very strongly that way and say, you know, let's talk about this solution for what's happening in Uganda right now with the banana diseases that are killing the major food source. We can fix those with a gene from banana that we just turn on all the time. You know, what's wrong with that? And they have a very hard time defending those positions. Shared values.
Yeah, there's a question back there. If you had a question, sorry. You have to hold the mic really close.
So you mentioned about safety. Can you give us an idea of the timeline, sort of like how from the lab to the table, how long it takes in general, for the genetic plant that's in the lab, what has to go through, I don't know, FDA or some regulatory body, and then when it gets basically commercially available.
Yeah, so it varies, okay? When you have a new gene, never been introduced before, and it's a gene from another species in a different species. So the thing like the BT gene that protects the plant, the bacterial gene that makes the anti-insect protein, that took a long time to deregulate. That can take as long as, it has taken as long as 13 years for deregulation. Not all of that in the FDA. It goes through 3 sequential phases. It goes through FDA to see if it's safe to eat, goes through EPA to see if it's safe for the environment, and goes through APHIS, USDA, to make sure that it's non-invasive and can be grown in an agricultural context. And that first phase, that FDA food safety side, can take anywhere between maybe a couple years. That's the most rigorous side, a couple years, and maybe and 13. The food safety side for like a gene from apple turned off in apple, you know, that doesn't have to have rigorous tests. But even then, it doesn't have to have lots and lots of tests. It still has rigorous testing, mostly just for unintended metabolites. But nothing that's nice nowadays is we're so good at detecting so little. that we can do very, very good comprehensive profiles on the chemistry and gene expression in different fruits and vegetables, that we can know exactly what's in there compositionally. And it's a very good way that we can ensure a high likelihood of safety.
I had just, oh, sorry.
It's related to flows with that. So you mentioned there's all these regulations, there's FDA, there's EPA, there's so now I'm trying to think, like, what's the public opinion, what part of this does that come into play?
Say the last part one more time.
Become a barrier.
What part of the what?
So public opinion itself, at what point does that become a barrier for getting across manufacturers and the lab to?
Is that a lot of the times the deregulation process is transparent, and you will have public comment periods where the products are talked about, the petitions are made public, and people can comment on them. And every single one of them that's ever been put out has been probably anywhere between 10-to-1 to 100-to-1 against deregulation. And it's just because it's much easier to scare people than it is to educate them. You also have a problem where those of us who trust science, we don't bother to get in there and say we really need this. Whereas activists they're paid to go on there and do it. You know, I mean, that's what a lot of them, that's what they do. So it's that, but it's just a general public sentiment. The other big issue is that the government and the companies, the worst thing that could happen would be for something bad to happen to people using these technologies. Because not only would it condemn the process, it would also make technology unavailable. So it's whenever there's a lot of pushback, it really makes it's very much in the interest of the companies and the government to make sure they get it right.
Hello. So one argument that I've heard several times is that although GMOs do have benefits, they're not that big, for example, in terms of increasing yield. Yes, increasing yield, but not by that much. So you're not going to solve the world's poverty by using GMOs. So perhaps it's not really worth making the effort of convincing the general public that they should all be using GMOs. So what would you say to that? If you were to think that question to you, what would you say?
Okay, let me make sure I got your question right. Could you restate that?
Yeah. So the question is, some people say, I have heard people say that the benefits of using GMOs aren't that great. So that although, for example, you could increase the yields, or you could feed more people by using GMOs, but those benefits aren't really enough to solve the global problems and because the overpopulation will have too many mouths to feed. Just by using GMOs, they're not going to solve that issue. And so I've heard people say that since it is such a complicated issue, since there are so many people that are against GMOs, and given that it won't be the ultimate solution, perhaps it's not worth discussing it at all, and we should just
Okay.
So that's the question. So what would you say to that?
Can I add just really quickly to that, like the issue of food waste and how that's a big issue in the United States, and the distribution of the crops, how they're taken from field to household, or the GMOs are distributed from where they're developed in the United States to other countries.
Yeah, I think and also the question of yield came up in there too, right? Just give me a thumbs up. Okay, so yeah, that's so cool. Yes, the issue about yield is an interesting one, because they haven't shown in all cases a big benefit to yield, and sometimes yield is lower, sometimes it's higher. But it's important for us to remember that these plants were never engineered with yield-related genes. They were made with genes to protect them from insects, or to give the same yield with a lower impact herbicide that can allow them to grow and knock away their competition. If a grower can get the same yield for half the cost, then that's a good thing. And so these save farmers money, and they save fuel, and they save labor. And that's been one of the universal benefits. So much so that in the developing world, you even have more acres growing in the emerging world than you have in the industrialized world. And so one of the legitimate criticisms is, well, there's no yield, there's no major yield increase. Well, of course not. We haven't put in those genes yet. And the reason we haven't is because of public pushback and those kinds of issues. Plus, yield is a tough thing because everything's got a price. You know, where do you get the if you're going to make an extra ear of corn per plant or extra soybean mass, that's got to come from somewhere. And so until you can finely tune things like photosynthesis, nitrogen acquisition, all the other stuff that you need to do to make a soybean, you know, that's a tough call to make. But what you can control is keeping the pests away, you know, and that's an easy one. So that's why you've seen those innovations. With respect to things like distribution and the developing world, it's true that we do make a lot of food, and there is a lot that goes to waste. But the way to have food sovereignty and independence and food security is for people to grow the crops they want to grow where they want to grow them. And if genetic engineering gives them the opportunity to grow a traditional crop where they are, rather than have to use fuel and labor to import it from somewhere else in a supply chain that can be disrupted, potentially by weather or by hostile forces in some parts of the world, let people take care of themselves, empower them to grow their own. And that's something that we can do with this technology.
All right, and I think that's all the time we have for questions. So please join me in thanking Dr. Folta for coming. And
thanks, everybody.